Okay, so we know what we're doing in theory. Now let's actually do a problem. So the first thing we're going to do when we do a Gauss-Jordan problem is we are going to write it in a matrix. So we're going to take this and set it up as 3, -4, 12, 1, 6, 5. And as your problems get bigger, it's okay to label the above your columns to remember this is the x's, this is the y's, but you may not need to for something this small. Okay, now the steps say we are going to get, eventually, we want to have ones in the diagonal, zeros everywhere else, and then numbers over here, right? Well, don't worry about turning these into ones until the very last step. Our main goal, how we're going to look at it, is just we want a number there. We want a number, let me use a color. We want a number in this spot, and we want this to turn into a 0. So, just like elimination technique, think of it from the original problem for the first step. Say, what would I need to multiply by? One of the equations can be either one, so when I add them together, it's going to make a 0. Well, hopefully you're saying I would multiply the bottom equation by -3, right? Okay, so we're going to do the same thing, but here's how we do it in a matrix. We're going to say take the second row, right? So we're going to think of this as row 1 and row 2. We're going to take the second row, and this, here, let's get rid of this. Okay, take the second row, and we're going to multiply it by -3. So notice I'm still using the same notation as we would have for multiplication, right? Times -3 times -3. So I'm going to take row 2, -3, and then I'm going to add it with row 1. And then I'm going to take that answer, and we'll get to that in a second. Actually, let's just do the math. So, and if you need to, you can always do side work. And I always say, just if you write side, then what this does is it tells me don't grade it. This is chicken scratch. This is just kind of off to the side, and I won't grade it for mathematical correctness. This is just your thought process. So for the very first one, I'm going to just do it out, not in my head. I'm just going to do it on paper. So I'm going to take row 2 and multiply it by -3. So -3 times 1 is -3. -3 times 6 is -18. -3 times 5 is -15. Then I'm going to take row 1, and I'm not going to multiply it by anything, because that's just going to be 3, -4, and 12. And when I add these together, -3 and 3 makes 0. -18 and -4 makes -22. And 12 and -15 makes -3. So now, where do I want to put this? Do I want to take this equation? 0, -22, -3, and do I want to put that in row 2, or do I want to put that in row 1? Well, as we said before, we want a 0. We have a 0 in the first column, and we want it to be in the bottom row, right? We want that 3 to stay a number. So therefore, I'm going to take my answer and put it into row 2. And by the way, we're always going to do that. If you're following the pattern that I'm setting up for you, you're always going to take this answer and put it into row 2. So row 1 stayed exactly the same. Okay, and so this notation is just building our equation, our new equation. It does not change our original one. So, and then we're going to take this answer, 0, -22, -3, and we're going to put that in row 2. And there we go. That's our first step. So let's recap. That's one step of this. The process is you always start with the top left corner. Use this number to get zeros below it. So I do a combination of the first row and the second row. I multiply them by something, add them together, and then fill the answer into row 2 to get a 0 there. Do not try and get creative and work in the other columns. Always just use the top left number to get zeros below it. So looking at our new matrix, we have a number in our top left corner, and we have a 0 below it, which means we're done, okay, with that part. So now we're going to move across the diagonal and focus on the next number, this one right here. So we're going to say now I need to use this to get a 0 above it, because again, our eventual goal that we're trying to work towards is ones in the diagonal, zeros everywhere else. So I have a number in the diagonal, I need a 0 above it. So I'm going to say to myself, what do I multiply by? So when I add these together, I'm going to get a 0. Well, does 4 times anything make 22? 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24. Darn it! All right, so maybe I have to multiply both things. So what is the smallest number that they both go into? 44. Multiply 22 by 2, multiply 4 by 11. Perfect. All right, so I'm going to multiply, and I have to make one of them a negative, one of them a positive, right? So I'm going to do a negative, whoops, I have to do my row 2 and multiply it by 2. So I'm going to do negative 2 row 2's, right? Plus 11 row 1's, perfect, to make a new row 1. And if you're not sure why it's a new row 1, watch the numbers and you'll see it again. You'll see it here. All right, so for our side work, negative 2 times row 2, 0. Negative 2 times 22 is 44. Negative 2 times 3 is 6. And then now for I need 11 times row 1. So 11 row 1's, that would be 33. Negative 44. And 11 times 12, 11 times 12, I'm going to just do in the calculator, just to be safe. Doop, doop. There we go. What did I just say? 11 times 12, 132. Perfect. And now I'm going to add those together. So I get 33, 0, and 138. All right. So I'm going to take that and put it into a row 1. Why am I putting it in row 1? Well, notice it has a 0 in the second column. So if I fill that in, that 0 will go right there, and that's exactly what I want. So I'm going to leave my second row alone. And I'm going to take this equation here and move it up to my row 1, which will give me 33, 0, and 138. So what does that do for us? What does that do? Well, now you'll notice I have numbers in my diagonal and zeros everywhere else. So that means I'm done. I've got Gauss-Jordan finished. So now all we need to do is get 1's there. So we need to, instead of having a 33 and a negative 22, I need to get 1's. So what am I going to do? Well, that's really simple. I'm going to take row 1 and divide it by 33. And I'm going to take row 2 and divide it by negative 22. Very simple. And so what does that do? My row 1 divided by 33 becomes 1, because 33 divided by 33 is 0. 0 divided by 33 is, 33 divided by 33 is 1. 0 divided by 33 is 0. And 138 divided by 33 is actually 3 goes into both of those, so that's going to simplify. But I'll write it as 138 divided by 33, just for simplicity. Then 0 divided by negative 22 is 0. Negative 22 divided by negative 22 is 1. And negative 3 divided by negative 22 would be 3/22. So now we can just simplify the fraction. What goes into 138 over 33? Well, 3 goes into both of those. But you can also just want to use the calculator just to show you guys, for those of you who may not be have seen this. 138 divided by 33. Enter. And you can do math arrow frac. There we go. So that's going to give us, that fraction simplifies to be 46/11. And then 3/22 does not simplify, so we're going to leave it at that. So now we say to ourselves, what's the answer to the problem? How do we find it? Well, the first equation is x equals 46/11. The second equation is y equals 3/22. So the solution is 46/11, 3/22. Now, you might be saying, Professor Dwork, not really a fan of this matrix thing. It seems like a lot more work. Can't I just do the other methods? Yeah, I know it seems that way, but when you have 17 equations and 16 variables or 17 variables or 18 variables, believe you me, this is way better, especially when I start letting you use technology to solve it for you. This is way better, okay? But I need you to understand the bones of this because it's going to come out and be really important later in some other sections. All right, so let's recap. What's the process before we move on to the next problem? Use the number in the top left corner to get zeros below it. Okay, then you do that. We have 3 over 0, so move down to the diagonal. And I'm now focusing on the negative 22. Use that to get zeros above it. We got that, so now we're done because we have numbers in our diagonal, zeros everywhere else. So then we just divide by the values. Divide by 33, the first row by 33, divide the second row by negative 22, and you're done. Okay, second problem. If you got I'm going to just make some room for myself. If you got the process, pause the video, give it a shot. If you want to watch another one, watch another one. Now, I'm going to cheat on this one a little bit. It's not really cheating, but I think hopefully we can follow this. If I were to write out the matrix, so it's 10, -1, 1, 7, 9, -2, 4, 7, 1, 2, -4, -17. Right? If I write it out, you might be noticing something. You might be saying, all right, in this, we always start in the left-hand column, so I'd be using a 10 to get zeros below it. But as we said earlier, one of our legal moves is to swap our rows. So make our bottom row become our middle row, or our bottom row become our top row. And do you notice our bottom row already has a 1 there? Doesn't it seem like it might be easier to, let's do a row swap. Let's swap row 1. Whoops, that's supposed to be a double arrow. Row 1 and row 3. Just switch them. So that way, I now have 1, 2, -4, -17, 9, -2, 4, and 7, 10, -1, 1, 7. There we go. Now, my math becomes a little easier because now I'm going to use this number. It's actually called the pivot value, which we'll explain in a much later section. But we're going to use the 1 to get zeros below it. So I'm going to use the row 1 and row 2 to get a 0. And you might be saying, oh, that's really easy because I'm just going to do -9 times row 1, add it to row 2. And then I can also use -10 for my row 3. So do you see why having the 1 there is kind of nice? So you don't have to. You could leave the 10 there and work with it. You'll still get the right answer. But sometimes when you see little things like that, it makes the whole process faster and a little easier. So here we go. I'm going to do -9 row 1s. I'm going to add it to row 2, and I'm going to make a new row 2. And simultaneously, I'm going to do -10 row 1s plus row 3 to make a new row 3. So notice, for each of these calculations, to get my new row 2 that's going to have a 0 in it, and to get my new row 3 that has a 0 in it, I have to use row 1 because that is my pivot value. That is the number that I want to keep. Now, some other people are going to tell you, if you get help from somebody, they're going to say, no, you don't. You could use the row 2 and row 3. Don't listen to them. They don't know where we're going. Yes, it's technically true for these problems, but I'm trying to get you prepared for something that comes later in the class called simplex method, where you don't have that option. So I want you to practice this now so it makes it much easier later. So use the top left number. If that's the number we're trying to keep, use that number to eliminate the number in row 2, and use that number to eliminate the number in row 3. So now, when you get better at it, this is how I'd expect you to be able to do it. We're leaving row 1 alone, right? Because we're trying to get zeros in row 2 and row 3. So now, I'm just going to do head math. I'm taking my values in row 1, multiplying them by -9, and adding it to row 2. So 1 times -9 is -9. -9 plus 9 is 0. -9 times 2 is -18. -18 plus a -2 is -20. -9 times 4 is 36. 36 plus 4 is 40. Now, all right, just to be safe, I don't like that 17. So -9 times 17 is 153. Okay. So -9 times -17 would be a positive 153. 153 plus 7 would be 160. Perfect. Okay, not too bad. Then for the next one here, we're going to use row 1 again to get rid of the 10 down here. So -10 times 1 is -10. -10 plus 10 is 0. -10 times 2 is -20. -20 minus 1 is -21. -10 times 4 is positive 40. 40 plus 1 makes 41. -10 times -17 is a positive 170. 170 plus 7 is 177. Okay, now there's our new matrix. We used our top left number to get zeros below. So what are we going to do next? Go down the diagonal. Use our next number we run into to get zeros above and below. So we're going to use this negative 20 to get a 0 at the 2 and to get a 0 at the 21. But I want to point something out, and this is kind of a nice thing you can watch for. This row, all these numbers are divisible by 20, aren't they? It is totally legal to divide all these numbers by 20. Row 2 divided by, and if you want to make it a negative 20, you absolutely can. So just because I told you you don't have to get the 1 right away, if it doesn't make your numbers bad, you might as well do it. You got to do it at some point, and if it's going to give me a 1 to work with there, and it'll make all my other adding and subtracting easier, you might as well do it. So 1, 2, negative 4, negative 17. You're going to take my row 2 and divide by negative 20. So negative 20 divided by negative 20 is 1. 40 divided by negative 20 is negative 2. And 160 divided by negative 20 is negative 8. Perfect. Then the bottom row is not changing, so that's 0, negative 21, 41, 177. All right, now, what does that do for us? That has made my pivot row really easy. It's a 1 again. Okay, so I'm going to do, to get rid of the 2, I need to multiply the 1 by negative 2. So negative 2 row 2's plus row 1, and I'm going to put the answer to that in row 1. Then, simultaneously, I need to get the negative 21 to go away. I need that to turn into a 0. So I'm going to do positive 21 row 2's. I'm going to add that with row 3 to make a new row 3. So here we go. I'm going to fill in my row 2 because that is the only thing not changing. And I'll start with row 1. I'm going to take all my values in row 2, multiply them by negative 2, and then add them to row 1. So negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Negative 2 times negative 2 is positive 4. Positive 4 plus 4 is 0. Hey, that's cool. Negative 2 times negative 8 makes positive 16. Positive 16 plus a negative 17 makes a negative 1. And that's it for that row. Bottom row. All right, so row 2 and row 3. So I do 21 times row 2, add that to row 3. 0 and 0, that makes 0. 21 times 1 makes 21, plus a negative 21 makes 0. Perfect. 21 times negative 2 makes negative 42. Negative 42 plus 41 makes negative 1. 21 times 8, that would be 168. Negative 168, negative 168 plus 177. So that would be, I'm going to be careful. My head math, when I'm doing all these big numbers, I can get myself into trouble. Negative 168 plus 177 is 9. That's what I was going to say, but I didn't want to risk it. All right. Now, you'll notice, I want to point out something. Because I worked from the top left and worked my way down across, the zeros I had created in that first step they remained. They did not get messed up because I worked across the diagonal. If you try to get creative and work all around the matrix and don't go in the pattern I'm showing you, you end up introducing numbers where you've already gotten zeros. So if you follow the pattern, use the top left number to get zeros below it, move in the diagonal, use the middle numbers to get zeros above and below, and then now we're going to move in the diagonal to our next pivot. You'll preserve your zeros you've created. You'll never introduce any problems. Case in point, well, check this out. All right, so down here in the bottom corner, we have a negative 1. So if you wanted to write out the whole matrix again, you could to turn it into a positive 1. I'll just wait and I'll do that in the last step here. So what I'm going to do is use this negative 1 to get zeros above it. And I said, hey, this is cool because we already had a 0 in our first row. So that's less to do. So all we have to do is get a 0 in our second row. So I need to multiply my row 3 by negative 2. Negative 2 row 3's. I'm going to add that to row 2. And I'm going to take that answer and put it in row 2. So row 1 is not changing because that had the 0 in it already. Row 3 is not changing because that is our pivot row. So now I'm just going to use this to get our new middle row. So I'm going to take my row 3 values in the black matrix, multiply it by negative 2, and add it to row 2. So negative Oh, 0 plus 0 makes 0. See, it preserved. And then here we go. I'm going to multiply negative 2 row 3's. So that's 0 plus 1. That makes 1. Look at that. It preserved. Okay, negative 2 times row 3. So that makes negative 2 times negative 1 is positive 2. Positive 2 plus negative 2 makes 0. Negative 2 times 9 makes negative 18. Negative 18 plus a negative 8. That would make... Yep, that's right. Sorry, I apologize. Negative 18 plus negative 8, that would make negative 26. So now our answer would be, we're basically done. All we have to do, we have ones in our diagonal, zeros everywhere else. I just have to turn that into a positive one. And you really don't have to, because can't you kind of read this answer already? But row negative, I'm just going to take the negative row 3 and make it into a new row 3. So therefore, I would have 1, 0, 0, negative 1, 0, 1, 0, negative 26. Let me make this a little bigger. 0, 0, 1, negative 9. All right, so my x equals negative 1, my y equals negative 26, my z equals negative 9. Or, we haven't done 3D yet in this class, but it's pretty simple to kind of come up with the idea that we're just going to write it as an ordered triplet, where normally we do x, then y, then z. Well, now we're going to do, we normally do x, then y, so we just put the z on there, alphabetical order. Perfect. So there is our solution. All right, so that is Gauss-Jordan. That is how you work with matrices. The notation is very important to me, that you're doing all of this row 1 plus row 2 to make a new row 2, etc., because on your test, when you have to do this by hand, I need to be able to follow your work. It can't be magic occurring on the page. Also, for later on techniques where it's not going to be a pattern and it's not something your calculator can do for you, you really got to be solid on this. So when you're doing your homework, it is super important to me. You do as many as you need to do by hand so you feel comfortable with the process. Once you've got this process down, it is absolutely 100% fine with me for you to do the rest of them using the calculator. I will also say the ones I have you do by hand will be nice, simple numbers, nothing horrible on the tests. If the real world numbers, the real world values, the decimals and fractions, I'm just going to ask you to put them in a calculator and get me a value. Okay? So in the next video, we're going to talk about how to do this in your calculator. And as always, we'll see you in the next video.